Hey everyone, today I want to discuss a little bit of Rust with you, specifically Rust atomics and memory ordering and threading. And what we will be doing is a very simple example, but it can be extrapolated out. And really, what I want to give you today is a bit of intuition and around memory ordering for threading. So what happens here is we're going to firstly import the thread from standard, time from standard, and the atomics from the standard library. It's under the sync thread. And what happens is we have, I'll only focus on relaxed, acquire, and release today. These, of course, sequentially consistent. I probably will do that in another video. So we have a static variable A, and this is what's going to be shared amongst our threads. So before we start, I want to just show you is that it's very easy or much easier to imagine that we have color coding on our threads, one being the main, the other being the underscore T thread. T is for thread actually. And so what's going to happen is that we can think of this piece. I'm going to suggest we think of it as blue. The main thread is blue here, right? Which means then that all of this above the thread, yeah, is blue, as well as everything below. Okay, just imagine it for a moment, and then everything inside of this thread spawn call. That's the closure there. We're going to call this thing orange. So think of it as two things. One is blue and orange, right? So now what I want to look at is we start the program execution from the main method, right? Then it's going to come and it's going to say A, we're going to store one value, and it's going to be with relaxed ordering. We'll talk about relaxed, but effectively there's no ordering constraints on relaxed, right? It's relaxed. So what we're saying is that for our blue thread, we have the thread is taking a value of 1. There's originally a value of 0 inside of this atomic A, which is of type U16. We're putting in 1 into it, and we relax. We have no ordering on how this will be um, uh, executed by the CPU or optimized by the CPU or the operating system. So what happens is that's our first action. Now what happens is on our thread, let's think of it as the orange underscore 3 T thread. And what's going to happen is we're saying that not on the blue thread, but on the orange thread, we want to load this value out of A. And we're going to do it with acquire, right? Acquire matches up with release, which I will explain later. What's going to happen is we're saying we want to print out the value inside of this thread, and we will either check if it's going to be 1, 2, or 3, just to see. So it's going to be true or false for these particular values. Right? Now, you might say that, okay, at this particular point, when we load it, therefore, A must be 1, right? If we're looking at it linearly. And I agree with you, it probably should be 1, yeah. When we load A, so X should be 1. However, the problem is that while this thing is executing, the orange thread, the blue thread is also executing. So by that time, we conceivably could have A dot storing 2 into this thing with relaxed ordering. So the A value will in fact be getting a 2 into it while it's still being printed on the blue thread. And now I want to actually show you something. So unfortunately, it's possible, of course, that our main thread will be able to complete, as in it will hit this exit here of the clause before we print. So what I'm going to do is I'm going to force it to join with the main thread. So from the main thread, which is making this thread, I'm going to join it. What that means is I'm going to wait on the main thread until T or T underscore completes, right? So what's going to happen is, and by building to intuition, we can sort of make a guess about it, right? So now I'm going to say that my guess is that A will in fact be 2. So therefore, we expect false, true, and false. Let's check it out. That is correct, right? False, true, and false. meaning that it's not 1, as we thought it might be here, as we thought that this thread might see it as 1, but it's actually 2, which means that, and it makes sense because this main thread waited until this thread was done before it completed. Therefore, it didn't just race away, and we actually were able to change it to 2 on the blue thread, the main thread, and then check it on the orange thread. Right? And now what's going to happen is that I'm going to introduce a different piece now, which is going to be release. Okay, so we can go like this, and we can go like this. Now what's going to happen, I'm going to show you later on why we will want to wait, but at this moment excuse me, we have a.store3. So what we're saying is that from the main thread, the blue thread, we want to add 3 with release, right? Ordering. Now, I said to you earlier that release coordinates with acquire. So what that means is that over here, we have a value from the blue thread. There's 2 threads now. The blue thread puts 3 into it, right? Into A. And then it says that it is release. Now this, it will effectively, what it's saying is that I release my hand upon the value 3 and I put it into A. So I release it. Now it's ready for someone else, the orange thread, to take it. So the orange thread says, okay, I will load this value. I pick it up with acquire. And these two, release and acquire, they essentially create a happens before. What that means is that over here, the blue thread first will store 3, and then the orange thread will read the 3 value. That's the point we're trying to get at. It happens before. So effectively, on the value A, we have the store release, and then we have load acquire. Okay, so that's the order this happens before relationship that's taking place. Effectively, we also had happens before with this this join, because what we're saying is that the main thread will not run or complete before the underscore t thread has done. We essentially join to it. Right? Now, if we're going to run this thing, something funny is going to happen actually. It doesn't stop. And the reason is we didn't, the main thread actually ran and it completed before it just went right through, because there's no stopping this thread, right? Effectively, before we were able to print out or check our value, the main thread was already done and the entire application was completed. So what we want to do is we want to wait. Let's wait 10 milliseconds. Let's check this out. So let's run that again. And now we find that it's not 1, right? That makes sense. It's not 2 either over there, which is relaxed, but it is 3 that is true. X is 3. And the reason is because of this acquire and release relationship creating happens before, right? So what you can notice is that this is quite tricky actually. Atomics and synchronizing between different threads and creating this happens before relationship. And that is why I want to recommend to you a specific program that I like to use, which is called TLAPlus. TLAPlus. Here we go. So what is this thing, you might ask? Well, effectively, it is it's a program very much that you can download as free. And what happens is that you're going to be able to describe your algorithms and your processes using mathematics, or its equivalent could be Pascal, which is what you're looking at right now. And effectively, we will be describing the state in which various processes or threads will be changing shared variables. The point being that we will be able to know if our algorithms are incorrect in what we expect them to be by asserting certain values on them. I encourage you to download this application and check back to my channel soon. I'll be making many more videos where I'll show you how to reason about and have a better intuition around concurrency. So thank you for your time. I hope to see you again on the channel. And all the best with all your concurrency bugs that you will find in your code.